I'm Stephan Rauschenbach. Behind me this is the Electrospray ion beam deposition lab, and I want to introduce you now to our instrument which we are using for microscopy of single molecules, especially of very big single molecules like proteins, sugars, peptides. The Electrospray ion beam deposition lab contains three machines. One is a microscope in this chamber to image molecules. The second is a so-called preparation chamber to make the surfaces onto which we can place the molecules. And the third machine, a preparative mass spectrometer, which we use to make beams of molecules and place them on the surfaces that we prepare in this chamber, and then we move them into the microscope to look at them. So in this combination of scanning tunneling microscope and preparation chamber, we can make a surface that is perfect for atomically resolved imaging. And now we have the surface and we want to image molecules. On this other side there's the Electrospray ion beam deposition source, and this one we use to put molecules on these surfaces. This happens all the way back here on the deposition stage in this chamber. This is the deposition stage. Behind these little holes there would be the surface, and onto this surface we direct an ion beam of molecular ions. And we get molecular ions here in air by a technique called electrospray ionization. In the end, if we successfully deposited the molecules, we move the sample back with this manipulator, first into the preparation chamber, and then from the preparation chamber into the microscope. If we have the sample in the microscope, we can image it. And if we're lucky and we have a good sample, we get to see something like this. What you see here is a small part of a gold surface. The zigzag line is characteristic of this gold surface. So at the edges of these ripples, molecules like to attach, and here you see single die molecules. These are the bright spots that you... So we can also coat the surfaces completely with molecule. You see the same gold surface here, coated with a huge amount of molecular magnets, manganese 12 acetate we call them. If you look around for a diluted spot, you find the single ones, and you can see the molecular details. So these are rather big molecules, 2 nanometers in diameter, and the little lobes you can recognize at the single objects. These are acetic acid groups that you can recognize individually. So this is a protein. If you unfold the protein, you end up with the polymer chain with a long string-like molecule, and if you look closely at this molecule, you can see the single lobes along its chain, and these represent the single amino acids. If you take smaller protein-like, so polypeptides, like this one here, angiotensin, you see it will make a beautiful pattern like this hexagon. You can take a look inside and you see that the single hexagon is surrounded by 6 of the molecules and make this perfectly ordered, beautiful structure. Similarly, this one, bradykinin, very well ordered dimers, so always 2 molecules which find each other to make this structure. We are interested in the structure of molecules. This is fundamental research. We want to know how they look like, how they are arranged, how the molecules arrange themselves at the surface, and how they interact with each other, how they interact with the surface. This fundamental knowledge, of course, can be very important to other scientists that are interested in drug discovery or how biological systems function. For them, the information about molecular structure is very important, and we are now mastered this deposition technique so well, and it is so clean and selective that we can apply it to actually biologically relevant problems. In this lab you see an instrument that is completely custom built. This started as my PhD project and I continued it ever since. It is a wonderful project because it involves so many areas of science where you can work on. So it is surface science in the scanning tunneling microscope in ultra-high vacuum. You have to work a bit as an engineer with all the pumps and the vacuum technology. You can work on biological problems and biophysical problems, and I personally like to work on ion sources, so this has to do with hydrodynamics. So it's a very diverse work that I can do here. I hope this was interesting for you to see what we do with mass spectrometry, and I thank you for your interest. Goodbye.